Okay, so we could multiply it all out. That's one way we could take a derivative. So let me just do that really quick. Helps if you got a pen. So that would give me x to the fourth plus 2x squared plus 1. And then if we took the derivative, we would get 4x cubed plus 4x, right? Okay, so that's not terrible. What would be a second option? Not chain rule because we haven't officially learned it yet. We could do a product, yeah. X squared plus 1 times x squared plus 1. So we could do the product rule. Product rule says we take the first times the derivative of the second plus the second times the derivative of the first. And if we do that, what do we get? 2x cubed plus 2x plus 2x cubed plus 2x. And lo and behold, we get the exact same thing, which we should. All right, 4x cubed plus 4x, all right? So we're going to learn a third method today that would work for this function, all right, which is the chain rule. So that's one of the nice things about derivatives. Sometimes even if you get lost in the middle of what you're supposed to do, you can sometimes find an alternate way to get there, right? If you remember all the other things. Here is your affirmation. Don't let what you can't do stop you from doing what you can do. Okay? He was a basketball coach, I believe. John Wooden, isn't that true? You don't know. Okay. All right, it's all good. So we're going to use the chain rule to find the derivative of a composite function. So we're talking about Lindt chocolate today. Do y'all know what they make the truffles? Ooh, that's so good. I meant to go get us some and I forgot. Sorry. It's okay.
I'm so mad.
All right. Well, you'll just have to get over it. Okay. So that's all I got for you. Sorry, bud. All right. So let's take a look at this. So there's a couple of questions here, I think, four questions. Let's take a second and work through that. It's talking about how chocolate's made and then leads us through some input and output process. Work through those 4 things in your investigation with your group, and then we will discuss it. All right. Talk about how it applies to calculus.
It's either conching or mixing.
I thought it was conching.
It's one of those.
Well, is the chocolate paste this or the chocolate paste the chocolate after you mix it? You want to
Chocolate paste sounds like other stuff, so this is probably too. Mixing is probably too. I think you're right.
Okay, because I thought the beans crushing and then that was during.
Hey, I saw you working at UPS store.
Can you just like tell us the steps?
No.
The guy told
Darn
me.
it.
The inputs and outputs at each step.
Calculus. Do some calculus.
The first one. And then after that we get
Powder?
bean powder.
Bean powder?
Cocoa powder,
Oh,
right?
duh, yeah.
Why did I say bean powder? Okay. And then
After you put it in
you
cocoa
also
powder.
input like vanilla and sugar and
So
stuff.
and other,
So basically
powder and other
ingredients.
ingredients.
Yes. And then out of that we'll get the paste.
He was the guy that had like the marcher.
And then you input the paste, and after that you get a chocolate bar.
Then after chocolate bar, you package it.
Yeah, so
We have a very
a product, yeah. If we got the steps wrong, we explained it in our best way possible.
That's okay.
Willy Wonka is like.
We don't really know because we're not really Wonka. So,
I've never made chocolate.
although some days I do feel like an Oompa Loompa.
Oh.
Just saying. An Oompa Loompa. Have you seen? Did you watch the musical Wonka, the movie?
The movie.
Yeah, it's good.
I studied
The Oompa Loompas are mean in that.
She was dope. And I met friends that we met, she was like 3 boys from around. She had, well, 4 boys. And then the one boy just turned around and acted like a weird freaking weirdo. And then I guess he was loyal or whatever. And the other boy just came over to share with us, and it was so funny. His name was Wesley was cool, the boy that was the sheriff. He was a weirdo.
Yeah, yeah.
And then Christian, the one that had a girlfriend. But I was like, Wesley, young children. I was like,
We
what
imported
tonight, you know? And I was like, yeah, came over and I said, no, it's called.
And we tried to ban them from saying.
But sorry, just whenever you
Yeah,
say.
we tried both the
Literally
house
both
and
the
the
house
house.
and the Senate tried that. Tried to have that law. No.
We are going to use the assembly line to analyze the performance functional characteristics. Let's look at
The
this.
sheet was way
The
more.
raw material is our input.
No,
Our independent
It is
variable.
on, yes.
What is the
But then
independent
we
variable?
denied
X squared minus 3.
Oh, yeah, whenever we, no, it's
Okay.
on square point subtract
And then sign it.
Me too.
Okay.
That was awesome.
Okay.
Ah.
You're wrong. Imagine evaluating, oh, you're right.
How do they square you?
I don't know what's wrong, but I mean, you're right. Imagine evaluating this function at x to 5. What happens first base assembly line? Line.
Yes, they go around
Square.
it a few times.
What's the final sine? Sine of
We
20.
have to be
Booyah.
To find the derivative of this function, we would need to consider how each function contributes to d. If blank equals x squared minus 3, what is derivative of d black box over dx? Yeah? Plugging back into our original function, we see that y equals sine of black box. What is dy over dy of d black box? Sine of 2x. The negative cosine of 2x.
That's not how mine is.
Well, this is just on first. So, I don't know.
I don't really know.
When it signs to the.
I don't really know. I'll just.
That's not good. Yeah, it's been a long week for so.
I know, it's been a hot minute.
It's been like
Yes.
so long since ago.
I can show you every time.
It's gonna go quicker though.
I was like, how can these parts?
We're gonna graduate soon.
Y'all are gonna graduate very soon.
In less than a pregnancy.
I still have this bottle like that.
Oh, great. Miss Mark.
I'll do that.
So can you just help me make sure that I put the stuff in for my ACT?
Yeah.
Because I
You had the paper.
yeah.
You just
I
put your
did it.
code in and then re-enter the demographic.
Yeah. It should be the same for the.
I did it, but well, I didn't finish doing it.
It should be automatically filled in.
Because it tells me I can enter my student code again.
No.
But then it says
Honestly,
my
it's all
portal
the
code.
cover correctly though.
Because I did it right here, but I don't know if it's supposed to look like something.
I mean, Tennessee goes.
Mm-hmm.
Tennessee Governor John freaking Summers rallying all the men and women of the world.
I think only Tennessee.
No.
Will it let you put it back in?
It's
Mhm. Okay, put it back in and let's see what happens.
We'll promote it, don't worry.
Oh,
It'll-
President of the world.
Exactly.
You don't have a tie. Oh, no, that's not that next time.
Just keep getting right here.
This is what better hold makes people aggressive.
So it works.
That's not nothing to do with me.
Forgive me.
Just so y'all know, I have become a barista. Not really, but
Oh.
I have. It's a good job. So I love flavored coffees, but I don't love the flavored coffee price, like at Dutch Bros and Starbucks. And I can't have all the sugar anymore, so I always put like a protein shake in my coffee, my iced coffee, and all that kind of stuff. And I have to do decaf because I got a weird heart. So anyway, so the only joy in my life are the flavors. All right, so there are these skinny mixes that I love to buy that have zero everything in them. And they have all these different flavors, but they're like $15 a bottle, and I'm not paying that, right? Y'all. Bills, however you say that store that's over there by Goodwill, has them for $4.99. My cabinet is full right now, okay? My current favorites, caramel pecan, donut, toasted marshmallow, white chocolate mocha. There's a peppermint. I bought sugar cookie shut the front door. It is so good.
That sounds good.
Brown sugar cinnamon. Like, I'm making all these different coffees at the house. Life is so good right now. So I may have to bring the Keurig one day,
Yes.
and we'll just have a flavor bar.
Yes.
Okay, all right, because it's really fun. Anyway, yes.
It says, the student code has already been matched.
Okay, so then you're good.
Okay.
Yep. And then did you change your recipients who you wanted to go to up there? So you can put recipients in. Who do you want the score to go to?
But then it takes me to my shopping cart. I'm trying to do this way.
Yeah, but it costs.
But it costs nothing.
See, my problem with
Yeah,
Square
because
Sense is
you're
that
paying
the
$0.
colleges that anti-sense scores to all require you to get the scores.
Gotcha.
It's like you get some free scores. Yeah.
You get 4,
I
right?
have to spend
The
money.
first four are free.
Yeah.
You must select which score you like.
Okay, so let's talk about making chocolate since now we're all hungry. Okay. Neve doesn't have her awesome pudding in here this morning, so I don't, yeah, it's okay. It makes me happy when I see it because it looks so yummy. All right, so what do you think is the first step in the chocolate? Roasting crusting the beans, I agree.
Booyah.
Booyah. What about 2?
That one.
Not packaging.
Not packaging, I would agree.
Mixing in other kinds.
Yeah, put the other ingredients in is what they say. Okay. And then what will we do? Yeah, that's an interesting word. And tempering, so you're heating and smoothing out the chocolate paste. Then finally we would package it. So then they ask us to list what are the inputs and the outputs. Like if I put something in, what do I get out in response? What would be the first thing we'd put in? Beans.
Booyah.
What do we get out?
Dried.
Yeah, we get crushed beans.
Cocoa powder.
Right? Maybe powder. We get some kind of cocoa powder. Okay, so then we put the crushed beans in and we add some more stuff to it. And what do we end up with?
Mixed dried ingredients.
Yeah, we get those mixed ingredients. Okay, then we put our mixed ingredients in and then we get probably that paste, right? And then finally, we do all the stuff we do to it and we would get the chocolate, right? So there's definitely a lot of different inputs and outputs. It's a multi-step process to make chocolate, which makes sense. If you've ever melted chocolate chips in a microwave, you know exactly what's happening here, right? If you go too far, it gets really gross. If you don't go far enough, it's not right. Like, it's a very exact process for making chocolate. Well, let's see if we can apply that a little bit towards math, because if we don't do it quite right, we get a mess, right? So let's look at the assembly line process to talk about a complex function that has multiple parts. So the raw material is our input or our independent variable. So if we're looking at that function, what would be our independent variable? Is it a secret? Okay. All right, so we were whispering it, but it is x, right? It is our independent variable. It's what we're going to plug values into It is our input. So now it says what happens when we evaluate this function at 5. What would be the process we would use, right? What would we do to that 5 first? Yeah, we're going to square the 5 and then subtract 3. And once we've done that, what would be our final step? We would y'all gotta quit. We would take the sign of our answer, which would be 22, right? Sign of 22. Which makes sense to us because we've been working with functions for a long time, right? We've been working with the order of operations. Well, that's not very much different for derivatives, all right? They have an order of operations. And so let's kind of talk about how we need to consider each link in this chain, right? Each process in this chain. So if our black box represents x squared minus 3, what would be the derivative of that black box?
2x.
2x would be 2x. Okay, so the derivative of our black box, which is that expression, would just be 2x. If we plug that back into our original function, so our black box back in, we're now taking the sign of the black box. Okay, well, what's the derivative of sine? It's cosine of the black box. Well, if we put both of those pieces together, we know the derivative of that black box was 2x. And so if we put it all together, we get cosine of x squared minus 3. All right? We get cosine of x squared minus 3. So how did that come about? What did we do, all right, to make that happen? All right, if we put it all together, all right, because we need all the different pieces. All right, how could we use them to get our end product, which is just dy dx? Any thoughts?
No.
It's Friday, we're tired. We would take that first derivative, all right, times the cosine of our black box. All right, so what did we do? Okay, here's one way to think about it. All right, dy dx is equal to the derivative of our black box with respect to x, so that inside function, times the derivative of y with respect to our black box, our independent variable. Right? And that's kind of where the chain rule comes from. We take a composite function, all right? So y is equal to f times g of x, all right? So we start with x, we plug it into g of x, and then take our answer and plug it into f, okay? But we have to take derivatives the same way, all right? We take derivatives with respect to the inputs. And because we're inputting different things, right, we end up with the chain rule, okay? So if y is equal to f of g of x, y prime is equal to the derivative of the outside function evaluated at the inside function times the derivative of the inside function, all right? And I like to say that in words. To me, it just makes a little bit more sense, all right? So derivative of the outside evaluated at the inside times the derivative of the inside. Okay, And that is the chain rule. And it's, to me, it's just kind of the top of the mountain when it comes to derivatives. It's something that we have to recognize and use a lot. Yes, sir.
Is it just me or does it feel like really illegal to manipulate derivatives algebraically?
Yeah, it does. Yeah. It's just, it feels like some weird, like we're doing some sneaky math or
It feels
something.
like the derivative sign is supposed to just be a symbol. Like you shouldn't be able to change it.
Oh, we're gonna change it a lot here in a minute. Yep, we're gonna change it a lot next week.
But you can.
Yeah, I know. It's fun times.
Weird.
Fun times. Math in its purest sense. Okay. So let's take a quick flashback, all right? Because one of the things that we're going to struggle with is recognizing when do I need the chain rule, okay? So recognizing a composite function, all right? Recognizing what is the outside function, what is the inside. Remember when we did all that work with decomposing functions, finding the outside, finding the inside? This is why, all right? So that you could recognize it to know what to do. All right, remember your composite functions, f of g of x, okay? How do we recognize them?
Oh,
Okay, so that's a composite function. So let's take a look at some and see if we can figure them out. Okay. So look at these. All right. We want to determine if the following are a composite function. If they are, let's identify the outside f, the inside g. Okay, so we're going to decompose functions again for just a second, just so we can recognize when I would need the chain rule. What about that first one? Is it a composite function? Yeah, for sure. Okay, what's your outside function? Square root. What's your inside function? X cubed plus 1, okay? So recognizing your inside and your outside, all right? We're going to go down the line. What about x plus tan x? Is it a composite? No, we're just adding two different types of functions together. That would be like general power rule, okay? What about the next one? 4 sine x cosine x. Is it composite?
No.
No, it's a product. Yep, good. Okay, product. This is just power rule. All right. What about the next one? Is it a composition?
Yes.
Yes. Okay. So my outside function is something to the fifth. What's my inside function?
3x plus 2.
3x plus 2. Okay. So recognizing what makes the composition. All right. What about the next one?
Yeah.
It's a yes. Okay. Trig functions to me are the trickiest. All right. F of x is the sign of something. G of x is that something, which was 2x. If it's anything other than a plain old x inside a trig function, it is a composition. Okay. And that for a lot of us is the hardest one to recognize. What about the last one, composition? It's actually a yes, okay? Let's rewrite this. Sine squared of x is actually okay. Sorry, I was getting a refill on my meds. Holy smoke. My husband said he looked like a toddler had been given money to shop for game day snacks. Individual packs of gluten-free Oreos and Chips Ahoy cookies. Oreos, Nutter Butters, and Chips Ahoy cookies regular for those of us who can't eat gluten. Turkey bites, so the little meat sticks. Pepper jack cheese sticks and Colby jack cheese sticks. I'm like, where's the pepperoni and the salami? We're ready to go. And a cracker. Anyway, all of that will make me sick. Anyway. Y'all, the last time I had salami, I threw up, so I can't eat it right now. Yeah. It was at a wedding, like right before they walked down the aisle.
oh.
I'm over behind the porta potties. Everybody thought I'd been at the bar. I had not. All right. It was bad. All right, so that last one actually is a composition. Sine squared is the same thing as sine of x the whole thing squared. And so now if we think about the outside function would be something squared, the inside would be sine of x. That one's tricky, okay? So everything on that right-hand side is a composition, okay? It is a composition. So let's practice, all right? Let me walk you through using the chain rule. I'm going to let you practice. We're going to look at some unique ways that it shows up where it combines all of our different rules and all the good things, okay? Good morning.
Hey, Hannah.
How are y'all?
Good. How are you?
I'm good.
Got some presents for you.
Oh, yay. Gareth Solomon. You have mail. It's about Dollywood. I've never been. Little jelly. Okay.
All the information on here except the name.
It's the 23rd. Oh, okay. All right. I only know that because it's written on a notepad on my desk. All right, so let's take a look. Let's walk through a couple of these together. Okay? All right, so the first one. First thing we have to recognize is it is a composition. Okay? This is the same thing as the sine of x to the 5th power. Okay? And so here's what we're going to do to find y prime. My outside function is something to the 5th. Okay? So let's take the derivative of something to the 5th. I would do what with the 5? If it was just x to the 5th, what would I do?
Put it in front.
I'd put it in front, and then I'd take it to what power? The 4th, okay? We're going to keep that thing that was inside, okay? So we're just going to keep the thing that was inside. Then we have to take the derivative of the inside, okay? So what's the derivative of sine?
Cosine.
It is cosine. So times cosine. Now, that's my derivative. The only way you can make that look prettier would be something like this. 5 sine to the 4th of x, and then cosine x. Okay, but it's the same answer. All right. So recognizing the outside, taking its derivative, keeping the inside the same, and then derivative of the inside. Let's look at the next one. Okay. I'm going to avoid a quotient at all costs. Okay. So how could I fix this so that I no longer have a quotient? I can make the exponent negative. Okay. And I highly recommend that. Once you know the chain rule, it's going to simplify a lot of these quotients for us. Okay. So now that we know the chain rule, my outside function is something to the negative 2 power. Okay, so let's do that derivative. Something to the negative 2 power says we take negative 2 times that 7 that was in front, which would give me what?
Negative 14.
Negative 14.
Does the negative 7 stay negative or it goes to positive?
This, oh, sorry, I didn't mean to make it positive. It stays negative. So that's going to make that a positive 14. Sorry, that's on me. All right. Now, think about it. If I have something to the negative 2 power, I subtract 1. What power is it going to be to now? Negative 3. Good. Okay. We're going to keep that 2x minus 3 on the inside. Okay. Now, let's take the derivative of the inside. What's the derivative of 2x minus 3? 2. Okay, so that's all the pieces of my derivative. Well, now let's just combine it and make it pretty. Okay, so I have a times 2 and a times 14. That would be 28. We don't want to leave negative exponents, so we're going to drop it back down and make it 2x minus 3 to the 3rd. Okay, much easier than a quotient. Okay, so chain rule makes it much easier than a quotient. Question. Okay, it's just learning to recognize the outside and the inside. Try that first one on number 6. All right, let's see how we're doing. What's my outside function? Cosine, good. And what's the derivative of cosine? Negative sine. Okay. We're going to leave the inside stuff the same, so x squared minus 1. And then times the derivative of that inside stuff, which would just be 2x. Simplify it. I got a negative out in front times a 2x, so a negative 2x sine x squared minus 1. Okay? We okay? Anybody want to quit? Not allowed. Okay, so you can want it, but it's not happening. Okay, let's do the next one. All right. Think about that one. What are you going to do? We're not going to quit. All right, try that one.
Look at that.
Well, this could just be 2/3 instead of doing the whole thing.
Yeah, that makes sense. Okay, so simplify that right now.
Yeah, simplify it before you take the and then just use 2/3.
Oh, actually, that's not bad.
That makes
Wait,
it better.
am I cookie?
Are you cookie?
Wait, I don't know, am I a cookie?
I'm gonna eat you. The derivative, do I take the derivative of this?
I think I could.
You take the derivative of this
I hope so.
outside, so you did that correctly, and then times the derivative of this inside.
Oh, enjoy.
Oh, I forgot about simplify. You know what? I'm gonna try it. I'll take a stab at it. If I miss, then cry. Yes. Or I'll just hope that I can quit. That will be an option.
Yeah.
Okay, hold on. Wait.
Why
Wait a
is
minute.
quitting not allowed?
Hold on.
Because quitters don't win.
Hold on.
Good thing I'm definitely gonna win.
You are.
So,
Please stay
why
with
do
me.
I have to use them?
We're going to win in May. I feel it.
Maybe.
Taking it again. Well, the luckily,
Credits just.
Test.
Sorry, I have sensitive teeth.
yeah, okay, so don't forget.
All right, what's a good strategy to start this one?
Probably make it to be 1/3.
Yeah, let's rewrite that root. I got x squared plus 2. I've got a cube root, but it also has a square under that. So what's that going to make my exponent? 2/3. Okay, it's going to make my exponent 2/3. So now when we start our process, my outside is something to the 2/3. So 2/3. I'm going to subtract it by 1. What's that going to make my new exponent? Negative 1/3. We're going to keep the inside stuff the same, so x squared plus 2. And then the derivative of that inside, which would just be 2x. And then if we simplify, 2/3 times 2x will give me 4x over 3. I'm going to bring that bottom expression down, make it a cube root so that it's positive, or you could have left it x squared plus 2 to the 1/3 in the denominator. Okay, so they're probably not going to leave you a negative exponent.
So, why did you put the cube root and the 3 in the same place and not just 4/3 over that?
Because that 3 would be in the denominator anyway, and when the exponent's negative, I just drop it to the denominator.
Okay.
Okay, let's look at some that get a little bit more complicated.
Thank you so much.
You're welcome. I don't like to leave you any surprises. Okay. So let's take a look at these. And it's not that they're terrible. Okay. They just use more functions. Okay. Terrible's coming. We're not there yet. All right. Dun, dun, dun. All right. I really wish I had music where I could play. Becca has a sound machine. So like, you know, if she likes her joke, she hits the laugh button. So it like, you know, it laughs. Her freshmen don't appreciate it. And then there's one that boos, like if somebody has the wrong answer, she goes boo. It's pretty fun.
Aw.
It's pretty fun. Anyway, all right. But she got those freshman boys to put on Cats makeup, so that's a win in my book. And I'm like, that's a huge win because they're jerks. Anyway, here we go. So y equals e to the sine x minus 3x. Okay. First of all, why is this a composite function? It's in the e, right? So if I have anything in my exponent with e that's not just x, it's composition, okay? So if it was e to the 2x or e to the, 2x squared, that is a composite function. This happens to have a bunch of crap in the exponent, right? So what's my outside function? It's the e. And the nice thing about e is the derivative of e is e. Good morning. Oh, you have pictures.
Thanks, bro.
Who is?
Aw.
She's not. Laura, she's not here today. You want me to keep it, and I'll give it
She
to her.
told me to give it to her.
Oh, okay.
Keep it.
Nope, you're good. I will not hoard it.
Sure you may.
Those are good pictures. Okay. All right. So we're going to keep the e. All right. Then we're going to keep that whole exponent. So sine x minus 3x. Now, we need to take the derivative of that exponent. So what's the derivative of sine? Cosine x. And the derivative of negative 3x? Minus 3. Okay? There's really nothing else you can do to that. Yes, ma'am.
Sorry, but I just don't understand how e is the outside.
Okay? Well, remember a function e to the x, all right, its derivative is itself. So it's kind of like a trig function. If there's anything in that exponent besides just x,
We need the sec team to the new wing bathrooms, sec team to the new wing restrooms.
Upstairs or downstairs?
male or female.
If
Do
there's
you
ever
need
a
an
crisis, they
AED?
don't want them calling.
Like, God bless.
Freaking Miss Miller.
That wasn't Miss Miller.
That was Miss Miller?
No,
That was a student.
Oh, sorry.
that was Miss Miller.
That sounded like Miss Miller. Okay, sorry.
You got to have a lot more details when you call for the set team.
Okay, sorry.
Okay, sorry, let's go back to e to the x. We got distracted. It got really crazy right there. All right, so you know how if we did sine of 4x, we know that's a composition. Sine's on the outside. There's something other than x on the inside. Same with e. E to anything, all right, is a composition. Yeah, as long as if it's, yep, and it'll always be the outside. Okay. The only way I think they might write this simpler would be to put that cosine x minus 3 in front, like a coefficient, but who knows? Okay, but it's still the same stuff, right? They might rearrange the order. Okay, let's look at the next one, right? So ln of the sine of x, okay, what's your outside function? ln. So what's the derivative of ln? It's 1 over whatever. Okay? So my whatever is that sine of x. Okay? But we're not finished because I have to do the derivative of that whatever. What was the derivative of sine? Cosine. Okay? Now, as I'm looking at this, all right, this gives me cosine over sine. Can I simplify that?
Sure.
Yep. What is it?
1. Oh, I'm joking.
You're allowed to joke.
Cotan.
It's cotangent.
Oh, yeah,
Duh. Right? We're going to use our identity. Okay? You can count on they would simplify that identity. Okay? All right. Let's do a couple more. All right? Just because they get more complicated. All right? And we got to look for all the things we know. All right? So let's look at this next one. Tangent 3x squared plus 4. All right? What's the outside function? Tangent. Okay. So what's the derivative of tangent?
Can I do the Hody High stuff real quick?
It's secant squared. Okay. Make you some flashcards. You got to know them. Okay. Secant squared, we're going to keep the inside stuff. Okay. And then times the derivative of that inside stuff. So what's the derivative of 3x squared plus 4? 6x. That does not go inside the secant squared. It goes in front of the secant squared. So 6x secant squared 3x squared plus 4. Literally sound like I'm coughing up a lung. Okay. All right. Okay. Let's look at the next one. All right. Y equals sine x cosine x all to the third. Okay. What is your outside function?
Third.
Something to the third. Okay. So we're going to take y prime equals 3 times that something squared. All right. My something was sine x cosine x. Now, when I take the derivative of that inside, what do you notice about that inside? Is it one function? It's a product. Okay? So when we do this inside derivative, we have to use the product rule. Okay? So this parenthesis is going to be ugly for a second. Okay? So when we do a product rule, first times derivative of the second, derivative of cosine would be negative sine, plus second times derivative of the first. Okay. Simplify a little. There's not a lot we can do there. 3 sine x cosine x squared. This is going to be negative sine squared plus cosine squared. So I'll just write cosine squared minus sine squared. Do not multiply that out anymore. Leave it be. Okay, that's gross. Leave it alone. All right, so you've got to look for, when I do the derivative of my inside, is it a product? Is it a quotient? Because you have to treat it differently. Okay, so that's where they'll get you, is those little things. All right, like that. Now, I'd like to tell you that's as terrible as the chain rule gets. All right, but we all know that's not true. All right, there's always something worse. Okay, and we refer to that as repeated use of the chain rule. And here's why. When we talked about our chocolate, was there just one input and one output? No, there were how many? There were a lot, right? 4 to 5, okay? Can you have a composite function that looks something like that?
Yes.
Yeah, you can. Okay, you can. So, do I have too many parentheses? I think so. No. Okay. So h of g of f of x, right? Just means we have multiple composite functions. Bless you. You'll also hear it referred to as a multi-link chain. Is that one word, multi-link? We'll put a hyphen in it and say it is. Okay.
Doesn't look good for our ACT.
I don't know. It's why I teach math, not English. Sorry. Grammar is not my strong suit. But we all know that, right? After a year and a half, y'all know.
That's a word, it makes sense. Yeah, it's mean everything.
But I mean, I used to could write a mean paper. That's all I'm going to say. Okay. But it's been a hot minute. So let's look at some multi-link chains. Let me show you what I'm, oh, not that.
Is that one?
Oh, Farfignugan.
Maybe those were the multi-link chains.
No, they're up here at the top. I just haven't worked in a hot minute. All right, so let's take a look at this one. All right, so let's see if we can find the extra composition along the way. Okay? There will still always be an obvious outside function. Okay? So if we look at that first one, g of t equals tangent 5 minus sine 2t. What is the obvious outside?
Tan.
Tan. Okay, so that's good. Tan is my obvious outside function. All right, so we're going to start with that. So g prime at t is going to equal secant squared. And then we're just going to keep all of that stuff. 5 minus the sine of 2t. Okay, so we see the obvious first outside. Okay. Now, here's where it gets a little tricky. When I get in there to take the derivative of that inside stuff, the derivative of 5 is not a big deal, right? What's the derivative of 5?
0.
0, okay? But if I look at that negative sine to t, that's another composition right there, okay? And so who is my outside on that piece?
Negative sign.
Negative sine. And so what would be the derivative of negative sine? It would be negative cosine. I would still keep its inside stuff, all right, which is 2t. But I'm not finished because that's that multi-link chain. What's the derivative of 2t? 2. Okay, so that's where it gets you. All right, that's that multi-link chain when we see it happen. And typically it's with trig functions. Okay, not always, but typically e's and trig. All right, simplify that a little. There's not a lot to simplify that. It's just kind of nasty. I would do negative 2 cosine 2t secant squared 5 minus sine 2t. That'd be about all I'd do to that. Okay, just to kind of rearrange the order of the multiplication. Okay, so you're gonna have to practice these to make sure you can see it. All right, let's look at the next one. All right, square root sine of 4t. Okay, so it's very similar, right? Rewrite it first. If you've got a root, rewrite. So 4t to the 1/2. That's going to help you to see that obvious first outside function. Okay, so my first outside function is something to the 1/2. And we would keep that sine 4t, right? But now as I look at that inside, that too is a composition. Okay, so let's start with that outside. The derivative of that outside would be what?
Cosine.
Cosine, and I would keep the 4t. And then times the derivative of that inside, which would be 4. Okay, so again, just to rewrite it, make it look prettier. All right, I have a 1/2 out in front and I have a 4 out in front. So 1/2 times 4 would leave me with what? 2. The cosine can stay in the numerator. The sine is to the negative 1/2, so let's drop it to the denominator. And I'm just going to call it the square root of the sine of 4t. Okay? What you think? You don't. Try not to think. It's easier that way. Just kidding. Okay? It just takes a minute, all right, to get used to seeing them. Okay? It just takes you a minute to get used to seeing them. All right. So let's look at these, okay? They're all the same values, expressions, but I put parentheses in different places. I put squares in different places. Let's talk about how we would do all of these derivatives, okay? When do we need chain rule? When do we not? Okay, take a look at that first one. Cosine of 3x squared. Are you going to need chain rule? Yes. Okay. So this is definitely a chain rule. Outside function is cosine, so the derivative is negative sine. Keep your 3x squared. And then derivative of 3x squared would be, good job. Oh, I turned the microphone off. Okay. Simplify, really all you can do is just pull that 6x to the front. So negative 6x sine 3x squared. Okay, let's go across this time. This time we put parentheses around the cosine of 3 and then an x squared. Composition? Yes or no? It's a no, okay? Cosine of 3 is just a constant. That's a numerical value, okay? This is normal power rule, okay? My variable, it's written weird. We probably wouldn't see that very often, but my variable is x squared. My coefficient is cosine of 3, okay? So if I do the derivative of x squared, I would take 2 times my coefficient, and x squared would go to what power? To the first. All right, that's weird. Okay, that's weird. Learning to recognize a constant. Okay, cosine of 3 is a constant. Another thing that it will get you is if you see a pi in front, we are so used to seeing pi as a symbol, we think of it as a variable, but it's a constant. Okay, so if that was pi x squared, the derivative would be 2 pi x. All right, pi is a number. Okay, weird. All right, let's look at this one. That's what parentheses do, they get you. All right, so y equals cosine of 3x, just the 3x is squared. Composition or no?
Sure.
Yes.
It is a composition, okay? So y prime, all right, derivative of the outside function, so negative sine. We're going to keep that 3x squared times, all right, inside stuff, composition or no?
Yes.
Yeah, okay. The inside stuff is a composition, so we're going to do chain rule again. That's going to give me 2 times 3x, going to go to the first power. And then derivative of 3x would be 3. Okay, so that one was a multi-link chain. So not only was it a composition, it was a multi-link chain composition. So we simplify that, negative 6x sine 3x quantity squared. Okay. All right, and then let's look at that last one. Cosine squared of 3x. Cosine squared of 3x. Composition or no? Oh, it's negative 18, isn't it? Yep, sorry. Y'all, I can't multiply. Because you got 2 times 3 times 3. Yep, thank you. Could we rewrite the last one before we started?
Yes.
Yes, we would write that as the cosine of 3x. The whole thing is squared. Okay, so when the squared is over the cosine, the whole thing is squared. All right, so now we definitely have a composition, right? So y prime's going to equal to, we're going to raise that to the first power, so cosine of 3x, right, times the derivative of the inside. Okay, so what's the derivative of cosine? Negative sine, we'll keep the 3x, and then times the derivative of the 3x, which is 3. So now we get negative 6 cosine 3x sine 3x. Okay, so all we did was move some parentheses and some exponents, and we got 4 very different answers. Okay.
Same problem.
Yep. Yeah. So we got 4 very, very different problems. Let's do one multiple choice before we quit for today. Okay. All right. Because these are the basics. All right. So we're going to practice the basics today. Monday, we're going to look at the AP style questions. How are they going to ask you about the chain rule? Okay. So, all right. Here we go. One multiple choice. Which one's correct? All right. Which one is the correct answer? This is the derivative they want you to do, secant of 2x. Mess with it a second. Let me go get your correct page number because that's not right.
Nothing.
Oh, whatever.
All right, which one do you think it is? 3. All right, derivative of secant is secant tan. And we would keep the same stuff inside. And then derivative of that inside is just 2. Which one do you think people pick most often?
2.
Okay, yep. 2 is one that they pick a lot, right? They only put the 2x with one of the functions. The other one that they pick a lot is 4. Okay, how do you think they got the coefficient of 4? They did the inside derivative twice. You don't have to. You only do the inside derivative from the original function. Okay, so secant's weird because you got to put that inside stuff in for secant tan because it's both part of the derivative. But the inside derivative we only write down once. Okay, so just as a heads up on that. All right, so just a few for you to practice. Page 165, 1, 3, 5, 7, 13, 17, 19, 23, 25, and 27. I'll post the answer key here in just a second. Okay, you do have a wrap up today on Google Classroom. All right, so I finally rearranged all of that. It's been posted for days. All right, so it looks like you have one lesson for this week. That's all. All right, and I took everything and just put it under a tab called First 9 Weeks so that it doesn't get all jumbled up. Okay, so then this week says week 10, I think. Okay, and 2 of your things for next week have already posted, but that's fine. Okay, and if you didn't turn in your maze on Wednesday, I need it before you leave today, so I could get that grade put in for this week.